Let's first make sure our audio is working. We can clip it this way. So, first of all, now I can read comments in an orderly fashion. Thanks for joining. And so, yes, I can read comments in an orderly fashion. And second, I have upgraded my cameras and my audio. And as for dinner, no, I was simply making sure that I was properly caffeinated for this activity. So, while I was grabbing my coffee, let's see. Skewed View, hey, how's it going? Big 3D. John Mack, hey, how's it going? And so, we have all the parts here for, first of all, I'd like to get confirmation that the audio is working. And it would help if I turned off that. There we go. Disembodied voice. I can fix that. How's that? Better? Or did you mean some sort of echo effect? Echo still. Better? Echo, I mean. Is the echo sorted out? Or is it still there? Okay, so I decided I was going to IRF, and then I looked at the pricing, and it said $10 to attend or $10 to exhibit. And I said to myself, self, because that's what you say when you talk to yourself. I said, self, I should get some exhibiting space, because in the worst case scenario, I'll have a place to store things while I'm on site, and in the best case, I might actually have something to exhibit. Then I realized it's really rude to grab up exhibit space if you're not actually going to exhibit something. So I figured I'd better exhibit something. I had been holding off doing anything to upgrade my A8 here for a while. My first name is Colin. Nice to meet you. I had been holding off upgrading my A8 primarily because I needed a solid frame for anything that I was going to do. I thought about putting linear rails on it. I thought about some other things. But obviously the first step is to move to extrusions. It was a pain in the ass. To find a set of extrusions, I looked at going and get a chop saw and buying the material myself and cutting it to size. The kit I found was on eBay for 50 bucks. Creek 3D, were you answering Skewed View? I want to make sure that you can hear me. Yes, my name is Colin. So I found a kit of extrusions for 50 bucks on eBay, and I figured, all right, good enough. The extrusions, or the instructions that come with, or that are distributed in the PDF for the AM8 suggest that you use the standard aluminum corner brackets, which are these. But those provide very little rigidity because you're basically securing the inside corner and nothing else. Well, I found pieces that are corner brackets that actually slide into the extrusion itself. Let's see if I can get a better view for you. Slide into the extrusion. There we go. Extrusion corners itself. Now I used it in a way I don't think you're meant to use it, by mounting it first to the outer bracket on the inside rail and then sliding the center bracket onto it. It was a pain in the ass, which is why I'm not doing it now. What I will be doing is mounting the interior corner brackets to provide the added rigidity of having the pieces secured at both corners, both interior and exterior angles of each corner, that is to say. It's not. I mean, I don't know if you can see this. It's not sturdy at all. I mean, it will be once it's all together, but an individual bracket is a point at which a thing can bend. If you have 2 points, obviously on every mating surface where a joint exists, the thing is that much more secure. So we're going to mate the interior and exterior corners. The interior corners will be mated with your standard corner brackets. Before we get into that, though, I want to talk a little bit about the massive pain in the ass of printing large amounts of parts and the relative uselessness of large print beds. So, my initial thought was the quote-unquote correct way of doing this would be to use the A8 to print all the parts for the AM8 and go along that path just to prove that it can be done for people who only have one printer. Now personally, I would never even attempt this if I had only one printer because I don't have that much confidence in my ability to go from successfully printing all the parts and finding that they're all printed perfectly, taking apart the A8, preventing me from printing new things, then and getting it all together without finding that one of the parts is off spec or one of the parts gets broken in assembly, etc. So anyway, I decided I was going to print all these things on my CR10, which of course has a 300 by 300 build surface, which is great. But in practice, first of all, it's a massive pain in the ass to level. And ultimately, I think I spent 2.5 hours doing 4 different iterations of leveling to get the thing fully trammed. And of course, you have to redo it I mean, it was never fully trammed really well to begin with, but you have to redo it for PETG because it sticks in particular ways or doesn't stick in particular ways. By the way, if you're printing PETG on glass, you want to do it with hairspray, not tape and not glue stick. Looks sturdy. Duct tape and Bondo. Yes, well, it's aluminum, so duct tape and Bondo would be a a step down, I think. So anyway, not only was it a pain in the ass to manually tram, I went through and figured, since I'm updating all of my systems, I might as well bump up from Marlin 115 to 118. Well, lo and behold, the board on the CR10 has less memory, onboard memory, than the board on the A8. It is literally an inferior board. It has slightly better MOSFETs on it, but with regard to memory, it's an inferior board. You can't actually compile in. If you were to take, what I did was I took the example default CR10 configuration that they offer, and went about to add probe manually, which allows you to sort of simulate the existence of a auto leveling probe. And probe and level by LCD. So you basically pick points and you manually level at each of those points, and it does the calculation with the matrix that you formed from all those points. It doesn't have enough memory to do that. So I went about yanking things out of the build until I had enough memory. Well, I couldn't get it done. I pulled out everything I possibly could. I was still about 100 bytes, and I was really that close. Not 100K, 100 bytes short when I eventually gave up. So anyway, I'm less impressed with Creality than I have been. And I never did get an answer in Walter and Chris's stream about whether Creality released their firmware configuration, their Marlin configuration for the Ender 3. But anyway, I got it all trammed. I set about printing these things. Now, most of you guys are coming from Walter's stream, and so you'll see in the Country 3D Discord chat, you'll see lots of pictures of these things being printed at various stages, and it sucked. What I learned is that even with a perfectly trammed large bed, getting PETG to stick to glass is a pain in the ass. And the other thing, which is even more important, is the larger the surface area that you're utilizing, the greater chance you have for acceleration effects. So belt slippage and these sorts of things. So, for example, all of these parts except this and this and this, these were all printed on the bed at once. And you can see the coloration. They're relatively dark. There we go. What is wrong here? I need to... All right, but you can see the layers are well adhered, but you do have these acceleration effects. You have a little bit of waviness on the y-axis, which is really irritating and not hugely problematic for most of these things. I mean, it's important that the motor mounts are flat relative to each other, but they will be because the acceleration effects are the same on all parts, so it's not going to be the end of the world. But it becomes a problem when you have mating surfaces like the y-axis tensioner. So I tested this out. I can't get this apart. It's together permanently. There's no forcing this apart. It's a goner. So these were printed at 0.15 millimeter layer height. I ended up reprinting. Let me see if I can get this just a little bit closer. Is that going to do it? Still not very good. All right. So I ended up reprinting this at 0.1. Now the difference between 0.1 and 0.15 is amazing. Absolutely amazing. The tolerances are perfect. The finish is perfect. The coloration is different, which is weird because it was the same temperature and the same filament. Now it is PETG, so it could be that this final piece has a little bit. PETG being hydroscopically sensitive, there could be a little bit more water content in this piece, but it is amazing. So you don't see, though, any of the acceleration effects because we were printing only these two pieces, oriented like so, on the board or on the print surface. Now, what I don't understand is why they weren't oriented this way. This would further reduce the acceleration effects. But anyway, because there were no acceleration effects, because there were no accelerations to get from point A to point B, you have a much, much higher quality print, which is great. Now, let's see about getting this thing together. We have lots of parts and lots of extrusions and lots of brackets. So let us consult the manual. It should be pointed out that I specifically chose not to disassemble the A8 before I began this because my assumption here is that I'm going to be able to keep the bed assembly as is, keep the X-axis assembly as is, and just slide it into place, having positioned the rods and so on. The electronics, we're probably not going to get to the electronics today anyway. But the electronics you swap out afterwards. But the mechanical stuff should just be a matter of motors, rods, and then putting in the bed, sliding the existing bed assembly in without disassembling it. And now I did have, I did print. These are not part of the AM8 build. The X-axis rod holders. I will link the Thingiverse models for each of these, but these were not included in the AM8 build. The default AM8 build has you use the original X-axis rod holders. I just wanted them to match, but if I were using the original X-axis rod holders, I would not have to worry about disassembling the thing at all because the belt would be contained and you could just slide it right off the X-axis, the Z-axis rods. But we're going to make this look cool because its whole purpose is to look cool on a table anyway. This filament is Nova Maker, translucent blue, in case anyone is interested. I bought it. I'm not big enough for people to give me filament yet. So, the manual suggests that we read the entire thing first. No. That we have tools. Yes. That we have an AM8, yes. That we have the plastic parts, yes. Oh, I should also point out that not all of these, besides the x-axis rod holders, I combined parts. I took parts from the AM8 build and also a set of models called the AM8. Not restructured. What was it? AM8 strengthened or something. I think that's what it was called. Again, I'll update the links when I have a chance after we finish here. So they're just a little beefier, and they wrap around better. So we have our brackets. We have our extrusions. We have our hammer nuts, and we have our M5 by 10s. Lots of M5 by 10s. So I guess first we're going to, this is going to sit outside of the base, which, bring this over here so you can see it. This goes like so. This sits on the outside. On the front, we have our motor holders. Right motor holder, motor mount, left motor mount. And on the back, we have two angle brackets each. Oh, there was something else I meant to bring over. Now, I'm going to play some hold music just because I have it, but this will just take a moment. First, I got to remember that I'm using a live mic, and I got to unclip myself now. But no, there are a set of jigs that I printed that come as part of that second build that I mentioned. Let me see if I can find the name of that thing just right quick. Having unclipped my mic, let me see if I can find, before I go grab these things, let me see if I can find the name of that updated AM8 build. The AM8 Reinforced. That's what it's called. All right, let me go grab these things. I'll be right back. Mics are a pain in the ass. Okay, let's try it that way. Okay. So when I'm doing this and looking at instructions, I should be looking at over here. All right. Let me see if I can catch up here. Krieg 3D, yes, accelerations are a pain in the ass. They almost never are. I don't think the net effect is actually ultimately useful in 90% of these cases. Yes, you need to cut accelerations quite a bit, and then in most prints, you're not going to benefit from accelerations anyway because your print is too small and you're not going to have an area over which to accelerate. And then when you do accelerate, you get, you know, ghosting and other crap. But the problem with the CR10 is that you actually have belt slippage. As you probably know, those of you who have CR10s, there's a really crappy tensioning system that just involves 4 hammer nuts, and if it becomes loose, you need 2 or 3 people to actually tension it again. You know, 1 or 2 people to yank it tight again, and another person to tighten all the nuts. So it's all 4 nuts, 2 on each side, to get it to work right. Let's see. Accelerations in half. Mad Mike, what? I'm not sure what that means. The guy making my sword real. Uh, let's see. Check back shortly. Oh, no. That's cool. I'm just making a specific effort to pay attention to comments because I haven't had an arrangement in the past where I had a screen that I could look at conveniently while I'm doing things. So, anyway, yes, it is a pretty blue. It is not the blue that I wanted. I wanted a metallic blue similar to what Joe, the 3D Maker noob, got for, and then printed parts for a Mark III. I don't remember the name of the vendor right now, but they are not available, or they don't ship to the US, so that was kind of aggravating. I meant to, there was an opportunity here that I could have taken to use the other snazzy item in my setup here, my new setup here, and it's always good to use technology just because you can, right? So what we can do is we can take a closer look at the bracketing system that I intend to use. So these brackets are basically just corner brackets that slide into the slots of the extrusion and are held in place with grub screws. Whether or not those grub screws are strong enough to do anything useful, I don't know, but in combination with the standard corner brackets, it should be fine. Let's put this over here for a moment. And you can see the same thing over here in the base, where it's kind of dark, where I did use them on both slots in the 2040 on the interior corners. No, I'm sorry. Both slots in the 2040 on the exterior corners. Right. So it's the exterior corner of this joint, this mating surface, and then on the interior corners, we'll put your standard corner brackets. Huh. Silk blue. Well, yeah, I don't know. So when I started working with this filament, this blue PETG, when I was looking at the first layers, they came out as sort of baby blue, and I was really irritated. That was really not what I was going for. But yeah, I mean they sort of ended up with this emerald blue, which is okay. Now, this piece, I guess we can toss, is useless since we have our snazzy one with. This makes me happy every time I play with it. The tolerance is being so perfect on this thing, and I'm guessing I did this wrong. Just going like that. Yeah. That fits better. Okay. So this is not quite square. That's not good. Now this is a glass top table, so it's definitely flat. What am I going to need to do to square this up? What is this? This is the one part that's really irritating about dealing with extrusions. Okay, we're not going to do the inside corners, we're going to do this on the outside corners. Okay, that's square. But yes, these style of corner bracket with the grub screws, you can get them on Amazon for about the same price as you would the T-nut style, and you know you can get them again cheaper on AliExpress, as you'd expect. but they're quite pleasing to work with once you've sorted out the angles that you need to go with. And of course, they do have the disadvantage of not being suitable for T-joints. But definitely an improvement over. There we go. All square, or at least more square than it was. So, let's put this aside, come back to this thing, and I guess we need to put, let's do it this way because it's easier. Two each of corner brackets facing in. There's our T-nuts. And this is where this stream is going to get boring fast. Hi, Rover. But yes, you join the stream just as it's going to get boring as I fight with T-nuts and getting them to rotate properly in extrusions, which, given these Chinesium T-nuts, is going to be a pain in the ass. So, let the fun begin. If I don't need to require them to rotate, I can just slide them in. At least in a few places, anyway. No, that failed. Yes, this is going to be a nightmare. It occurs to me I'm doing this the wrong way. I should be doing it this way. One hopes that I'm going to get much, much faster at this. CR10 clone would be interesting, but if you're going to do extrusions, why not do linear rails? I mean, V-slot extrusions are nice. Oh, and don't do T-slot extrusions. That's what the TiVo, is it the TiVo Tarantula? No. I'm thinking of the AM8 E10, I think. That was supposed to be the ripoff of the CR10. But they use T-slot rather than V-slot, and of course that destroys the wheels rather quickly, and just doesn't get the job done in the end. But I guess my point is, if you're going to do something like that, you might as well spring for the linear rails, because once you spent the money on the extrusions, why not? I think Walter's got the right idea. My next build after this, I think, is going to be a rail core or something akin to it. Maybe doing something with the E3D tool changer if I get really inspired. I don't know. We'll see. I can already feel myself becoming more proficient here. Check display here and make sure it's actually useful and in frame for people. There we go. It's a balancing act. You don't want to put the camera, allow the edge of the camera to be, edge of the frame to be too close to the edge of the table, because you don't really need crotch shots, but at the same time, most people work within, you know, 1.5 feet of the edge of the table. So, it's a challenge. So the default build, I think, says you need where's the bill of materials isn't here. Right, it's in the separate bill of materials. It said something like you need 22 M5 screws and T-nuts, and I find it difficult to believe that it would be that few. I ended up with 50 T-nuts, 100 M5 screws, and 25 corner brackets. So I think I'm going to be okay. But pricing on these things was, you know, between $2 and $3 per package off of AliExpress, which is perfectly reasonable. By far the biggest expense was the extrusions at $50. But I did a little bit of checking, and the cost of uncut extrusions is almost identical. These extrusions don't come tapped, which is irritating. One of the instructions is has you tap the bottom end of the vertical sections of extrusion because they want you to screw it into a base plate. I don't think that base plate is going to be necessary. I certainly hope it isn't, because I'm not putting it on. That is to say, I haven't printed it yet, so I might eventually put it on, but I haven't printed it, and so not right now. Right. So more. And two more. I still don't have enough screens. I find myself switching between chat and other things. But I'm trying. Is this the better method? Maybe so. Now there's a solid joint, and then it's restrained on both corners. This is definitely an improvement. And I think the total difference in price is something like $5 to get those extra outside corner brackets. And those are, I think, steel and not aluminum. Whereas these aren't aluminum either. I think the interior corner brackets that we're using here are zinc. Anyway, the point is not very strong relative to other choices. What is wrong here? I don't know if it's just not rotating. It's not creating a solid joint here for whatever reason. I don't know what's up here. This is very strange. So apparently the secret to getting these things tight is to run them out to the limit of their range, because there are slots in the in the bracket themselves where instead of just a simple screw hole, there's a slot. So you need to slide it out as far as you can in order to assure that it's actually holding the bracket tightly rather than just letting it flop around on its. What is going on here? Did it lose its nut? That seems to be the problem. Okay. So the actual problem is that the nut didn't turn, and it's screwed all the way against the bracket. So I need to unscrew it to the extent that we can. And this is the part of building with extrusions that I loathe the most. It's getting T-nuts that won't turn in there and secure things properly. Welcome back. I'm still fighting with T-nuts, and I imagine I will be doing this for hours. Hopefully it will be therapeutic for somebody. Okay, that's in this one. And this, I think, is actually owing to the size of the T-nuts. Ones that are slightly sized with tighter tolerances tend to work better, I've found. There we go. All right. On the bright side, there aren't that many of these that need to get done. But I'm not completely certain whether or not I'm going to be able to get a T-nut in there. We shall find out. I wonder, has anyone thought about doing assembly-based ASMR videos? There's got to be something therapeutic about it, or do you need to hire really beautiful women to do that? I don't know. Then again, if I'm going to hire a beautiful assistant to do my assemblies for me, then I've solved my problem anyway, and I don't really care about making videos about it. Or for that matter, I could hire a really ugly person to do it. Still have solved my problem, just wouldn't have the ASMR revenue. So next question is, do I need to put these on the bottom as well, and do I have enough? So we must consult the bill of materials. "93 screws are needed." Which means I am going to run out of nuts, because I think I bought 50. 110 square nuts. Okay, I screwed this up. "12 corner brackets." Okay, well, I have 25, which means I can put them on both top and bottom, and this thing will go nowhere. And to answer my earlier question to myself, the positioning of the outside brackets extends to the inner slot on the outer joined extrusions, if that makes sense. Let me make sure I can communicate this correctly, assuming people care. Right. So my concern was the my concern was this. You can't really see it that way. Let's switch to our snazzy mobile camera. Come on, snazzy mobile camera. Okay. My concern was that the outer brackets, which extend on this extrusion on the outside, see here, and then extend on the inner rail, within the inner rail of the joined extrusion. My concern was that they would extend too far in and I would not be able to turn the square nuts, the T-nuts, hammer nuts, whatever you want to call them, for the inner bracket. And apparently that is not a problem, which is good. And I have plenty of corner brackets, so I can do both top and bottom, and this thing is going nowhere. So, problem solved. Although I do need to order more T-nuts. probably means I'm going to have to buy them from Amazon, which means it's going to cost me an arm and a leg because I need them within the next 2 weeks. Irritating. I feel like I should put those bottom ones on only after I'm absolutely certain. 'Cause I thought I had 20. I need 12 in theory. 3, 4, 5, 6, 7, 8, 9, 10, 12. Okay. So part of this is I hope you guys can keep me awake while I do this. This is some seriously tedious shit. Oh, my coffee has been sitting here all this time. My coffee awaits me. It says, "Drink me, drink me." As coffee does. That one turned. This one. Excuse me. This is not holding. Why is it not holding? All right. And now we consult the manual. I'm not seeing comments. Okay, these need to go down, and then they need to be slid in that way. How do we slide them in? Oh, this is going to suck slightly. Okay. Let's do a little bit more first, though. There should be one on each side here. this backwards? I did this backwards. Damn it. Okay. So it's worth pointing out here that the vertical joint corner brackets should be placed on the bottom set of extrusions, not on the vertical section first. Primarily for ease of assembly. Thanks. Yeah, it's exciting. Party time at the assembly plant. The question then becomes, if I had done some section of pre-assembly to this, would that make it for a more interesting video? Well, maybe, but at what point is it no longer an assembly video? So for those of you here, unless you're just have it on in the background, and thank you for that, if that's the case. I could use something to keep me awake just as much as you guys can, so what's been going on? What have you been working on that's presumably more exciting than getting T-nuts to align correctly? Alright, so this is the back, this is the back, this is the front. Back meaning these have got to face front and there's got to face out. Okay. That's a bad strategy. Let's see. That's the back. That's the top. This is the back. Face this way. If I'm avoiding these plastic brackets that I don't think we need since they got the sturdier external corners, I wonder if I'm actually going to run short. I may not. And if I do run short, it's not going to be for the primary assembly. So, with that in mind, let us put our bottom corners in before we start putting things on the top that are going to make it a pain in the ass to deal with that. Have I rounded this over? Please tell me I haven't rounded this over. Please tell me it's that nut and not the driver. All right, well, we'll see. Yes, yes, it's definitely going to be stout. There's no question about that. Really, honestly, that's the big objective. I mean, there's no point in building an extrusion based frame if it's not stout. And I think this approach is going to yield an even more stout build than would otherwise be the case. My only concern is that I run out of T-nuts. Yes, I managed to I managed to make myself coffee before I started the stream. Well, before I sat down. I started the stream, I went to make coffee, I came back with my coffee, proceeded to set it aside and not drink it until moments ago. But caffeine is definitely nerd fuel. That's still not turned. Damn it. That's turned. No. That's gotta have turned. Why is this still? Oh, it's those. Okay. That's what we want to see. Okay. Okay, that's the back. This is the front. Mike, it's wonderful that you're still here. Thank you. Because I can imagine how exciting this is to watch. But we're getting very close. The next step after I get these two on here is to mount the the Y smooth rods, which means my A8 will no longer function as a printer anyway. That's the point at which I'm actually committed to getting this thing done. M318. I think that's the majority of A8 screws, one hopes. Okay. Okay. Now, smooth rods. And at this moment, I am going to take a little break. I will be back very shortly. That's not the screen I want. This is the screen I want. Okay. All right, back to it. Quick audio check. Okay, it's good. All right. And now we get to the point of no return, where we disassemble our A8. Let's get the wide angle view with our A8 in it. This doesn't really make a whole lot of sense, people. Let's go with this one. All right. Smooth rods. Smooth rods can be disassembled thusly. And it would help if I had a place to put my AM8 hardware. Let's not use that. Back. Okay. ANet disassembly. Portion of the ANet disassembly was significantly less exciting than I thought it was going to be. Oh well. So much for the y-axis. Yeah. This is the z-axis end stop, rod holder, come on, rod holder, rod holder with end stop, rod holder with end stop goes here, rod holder, and one more rod holder. Come on, rod holder. There you go. Ah. So that's the thing. That retained nut, let's see. This retained nut that goes here seems to float over top of the slot in the extrusion, so could easily disappear if it ever fell through. Huh. Seems like poor design. However, this is what they mean when they say assemble the rod holder. They mean put in the retained nut and the screwed M318 to hold it in. Perfect fit. So the rod holder assembly looks like this. So the rod holder looks like this, as does the rod holder with the end stop on it, which goes in the back right. Use an M318 through the through hole, through the and use a retained nut, which, if ever it falls out, is going to fall into the slot in the extrusion, which is not a good design necessarily, but I guess can't really be avoided. But that's what they mean by assemble rod holders. So I guess we will go ahead and assemble the rest of them and go from there. So we don't have a y-axis anymore. Bye-bye y-axis. If I was being responsible about this, I would have disconnected the belt before I did this. All right. Belt is released. That does make things quite a bit safer, at least for the belt anyway. I really need to get a transceiver for this muzzle here. We need the other 318s out of here. In order to properly assemble Where did our M3 nut go? Oh, there it is. That's one thing that the ANET did correctly. They were one of the first to do a nice job of mostly standardizing on a single nut and screw size. Okay, so at this point, locate the AM8 reinforced and see exactly which jig I should be using to align these end stops, not these rod holders. Okay, so there are 6 jigs. They are not labeled. They're all of different lengths, so we will simply line them up and figure out which one is which. Well, that would make this one the 51mm jig, which if you look at the AM8 reinforced, it tells you 51.4mm from the corners. And 47.4 for this one. All right. Back to the T-nuts. Z motor mount. Is this the Z motor mount? This seems like the Z motor mount. No, it's not the Z motor mount. Or the Y motor mount. Y motor mount. Or maybe it is. Yeah, it must be the Y motor mount, but how does it go on? Like this? Guess it kind of has to. This is where we need an AM8 reinforced picture. Show me the Z motor mount. Yep. That, I guess, is how it works. So the Z motor mount goes like that. And there are 5 nuts that hold that in place. Jeez, that's heavy duty. Heavy duty. All right. Okay. motor mount and idler. Does it say assemble the idler first, or just install it? Install it. $51, $43. All right, so there's this. I think is 51. $47, $43, $51, $47, $43, and $35. Okay. $43, that's this one. $43 is there. All right, so $43 goes there, and Z motor mount. Okay. Now there's slight warping on the Z motor mount, but I think it's going to be okay. I say that with no data on the subject whatsoever, but except that I'm guessing this amount of warp is not going to be a problem. Confidence in the face of no data. Very easy. I'm definitely going to run short quickly. $43. All right, so it's got to go. Actually, that's how to do this. Tighten down the top one first. And that holds everything else in place. These jigs are worth their weight in gold. I don't know why the main AM8 build doesn't include them. It does seem like an obvious thing to have. Nope. The main AM8 repo does not include the jigs at all, which is crazy because these things are awesome. Make life so much easier. Okay. $35. That is the tiny one. 35. That goes there. Those jigs are kind of awesome. Okay. I feel like I want to put the motor on next. Align the Y rods. That's a lot of flex. I'll be very annoyed if I have to reprint these Y rod holders. don't want to bend my smooth rods. Okay, so the left rod holders are screwed. The right rod holders feel like they're equally out of whack. This is why we really, really hate acceleration. Okay. Well, we're done for the night because these rod holders ain't no good. So I got to reprint the rod holders. If this is how it goes with every one of these parts, I'm going to be in deep trouble because I don't have that much filament left. All right. Well, kids, it's been fun. We will pick this up again tomorrow. Once I get new rod holders printed. I really hope the motor mounts are okay because those things took forever. While I'm thinking about this, what else should I reprint? Now these are going to be fine. Yeah, I should reprint the Z end stop as well. Rod holders and Z end stop. And if I'm going to do this, I might as well print them at one. I mean, that is a beautiful, precise fit. All right. Thanks for hanging out, those who hung out. And we will do this again once we have reprinted these parts and ordered more T-nuts. I don't know, like and subscribe and whatever else, I guess. And hey, if you hung out this long, you deserve a high five. Not to rip off Joel Telling, but hey, you deserve it. Later.